Welcome to A-Level Chemistry. Today we will go through the May-June 2021 paper 11, and while we do that, I will give you some techniques that you can use during the exams to get a good score. So before we begin, all I'd like to say, as always, is read the question properly because often when I was preparing for my AS level exams, I used to go through the questions very quickly and I always missed out some important detail. So if you really want to get a good score, you can't really afford many silly mistakes, and therefore I would really encourage you to read all the questions and underline any key concepts. So let's start from question 1. Which contains the largest number of hydrogen atoms? So the key word here is hydrogen atoms, not hydrogen molecules. So we have these options. Now we'll go through each one of them. First, always write the formula C5H12, which is 0.1 mole of pentane, means 0.1 times 12 hydrogen atoms, which is 1.2 moles of hydrogen atoms. Then butadiene C4H8, 0.2 times 8 is equal to 1.6 moles. Then H2, which is 1.00 into 2, which is equal to 2 moles. Remember, it's atoms. 6.02 into 10 power 23 hydrogen atoms. That's the definition of 1 mole. So the largest is obviously C. Then in which pair of species do both species have one unpaired electron? So we need to write down the electronic configurations for these species. So let's start with A. So Ar plus will be 1s2, 2s2, 2p6, 3s2, 3p5. Remember, argon is a noble gas, so it will have a complete subshell, 3p subshell, but Ar plus means one electron has been removed, so 3p5, which means there are 5 electrons in the p subshell, because there can be 6 in total, one of them is unpaired, so yes, this has an unpaired electron. What about the other one? Carbide ions, C negative, 1s2, 2s2, 2p3. Remember, it's 2p2 for carbon, but then it's negatively charged, so 2p3. And this has 3 unpaired electrons because remember, we always fill each orbital with 1 electron and then we start pairing the electrons up. So because there are only 3 electrons, each of them will be unpaired, so yeah, it does not have only 1 unpaired electron, so option A is crossed out. Then we look at option B. Boron is 1s2, 2s2, 2p1, and this is only 1 electron in p, it's unpaired, so yes. And then titanium plus is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So unpaired p electrons, but all the p subshells are full, so this is wrong, and therefore B can also not be the answer. Then we will look at C. So let's look at fluorine, which is 1s2, 2s2, 2p5. Again, 2p5, 1 electron is unpaired, so this is correct. And then we look at gallium. I'm going to write this down here because I'm running out of space. Gallium is in the same group as aluminium, and we know that if you write down the configuration of aluminium, the last subshell will be a p1, so only 1 electron in the p, and therefore 1 unpaired electron, and that's correct. So C is a good candidate, but we will always read all the options to make sure that we are doing things correctly. Then selenium negative will be selenium is in the same group as oxygen, so essentially selenium negative will have the same configuration as oxygen negative, and that will be p5. You can check this for yourself. And this has only 1 unpaired electron because 5 out of 6 in the p. And then Si negative will have the same electronic configuration as the C negative that we did in option A, because silicon is in the same group as carbon, and we saw that because the carbon negative does not have only 1 unpaired p electron, so the same case will apply for the silicon, and therefore we will cross this out as well, and therefore the correct answer has to be C. Question 3, phosphorus forms two chlorides, phosphorus 3 chloride, PCl3, which is a covalent liquid, and phosphorus 5 chloride is an ionic solid. One of the ions present is PCl4 plus. So it asks us for the shape of PCl3 and PCl4 plus ion, and so let's look at PCl3 first. PCl3 will have the same shape as ammonia, NH3, and you know that is pyramidal because it has one lone pair here and 3 bond pairs like this. So we narrow the answers down to A and B. And then PCl4 plus, we have options between tetrahedral and square planar. 4 bond pairs, so it's likely to be tetrahedral. 4 bond pairs, 0 lone pairs, and that's why it's likely to be tetrahedral, and therefore the correct answer is B. Question 5. Delta H01 is the standard enthalpy formation of methane. Delta H02 is the standard enthalpy of combustion of carbon. Delta H03 is the standard enthalpy of combustion of hydrogen. So, which expression is equivalent to delta H0C, which they have given here? Now, always make a Hess cycle before answering these type of questions because that makes life easier. So, we will write down this equation again. CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O liquid. And this is delta H0C. And then we have CS, the elements here, plus 2O2 gas, and this will be a Hess cycle. The left arrow will be delta H01 because it is the standard enthalpy of formation of methane, and the right hand arrow will be delta H02, which is the standard enthalpy of combustion of carbon, plus 2 into delta H03 because it's twice the standard enthalpy of combustion of hydrogen because you have 2 moles of hydrogen reacting in the reactants. So twice the standard enthalpy of combustion. So now we have this Hess cycle. So we know that delta H01 plus delta H0C is equal to delta H02 plus 2 delta H03. So 2 delta H03. So if we rearrange this equation and make delta H0C the subject, we will realize that the correct option is D, which is what delta H0C is equal to. Question 5. The diagram shows the Boltzmann distribution for the same gas at 2 different temperatures, T1 and T2. So they've given. Now before we delve into this question, we need to, let's decipher what this Boltzmann distribution curve means because that will make our lives easier when we answer the actual question. So we know that T1 is lower than T2 because as I taught you in one of the playlists, as the temperature increases, the Boltzmann distribution curve shifts to the right, the peak shifts to the right, and the curve becomes flatter. So T1 is less than T2. And Y is the number of molecules, X is the energy of the molecules. So we know all these things. Now let's read what the question is asking. What is plotted on the y-axis? We know. Let's stop there. We know this is the number of molecules. So we have narrowed the answer already to A and B. And which line represents the energy, represents the higher temperature? Sorry. So we already know T2 is the higher temperature. So the correct answer is B. And that's how we solve these questions quickly. What is the minimum mass of oxygen required to ensure the complete combustion of 12 dm cube of propane measured under room conditions? So we know that whenever they ask us these sorts of questions, always write down the balanced equation first. So C3H8, which is propane, plus 5O2 gives 3CO2 plus 4H2O. This is the balanced equation. And we know that the ideal gas equation is equal to PV is equal to nRT. But we also know that we don't have to use this equation because we know that at room temperature, under room conditions, each gas will, 1 mole of each gas occupies 24 dm cube. So if 12 dm cube of propane is being burned, that means half a mole of propane is being used. So half a mole of propane will react with 5 moles of oxygen because they are reacting in a 1:5 ratio. Sorry, 1 mole of propane will react with 5 moles of oxygen. So half a mole of propane will react with 2.5 moles of oxygen, 1:5 ratio. So we have 2.5 moles of oxygen, and therefore the mass of oxygen will be 2.5 moles times the molecular mass of oxygen, which is 16 into 2, and this is equal to 80. And that's what the answer is, B. And then question 7, why is the first ionization energy of oxygen less than that of nitrogen? Now, before we answer this question, we know this the reason why, and therefore let's say it out loud. The first ionization energy of oxygen is less than that of nitrogen because nitrogen has a half-filled subshell, but whereas oxygen has paired electrons which repel each other through spin paired repulsion. So we know that, and now let's see which option will correspond to that. Is it A? No, that's wrong. The nuclear is it B? The nuclear charge on the oxygen atom is greater? No, because nitrogen is to the right of oxygen in the periodic table, so the nuclear charge will be greater on nitrogen. And is it C? The oxygen atom has a pair of electrons in one p orbital that repel one another? Yes, we just did that. But we'll always look at all options. There is more shielding in an oxygen atom? No, that's not right, because the shielding is almost negligible across a period, and even if it changes, there's a slight increase across a period, and oxygen is before nitrogen, so there cannot be more shielding. Now question 8, which gas would behave most like an ideal gas under room conditions? So again, before we delve into the options, just remember that the ideal gases, which are the noble gases, they come closest to ideal gas conditions. So the noble gases come closest to ideal gases under room conditions, and therefore we see two noble gases in the options, and so just mark them, because obviously any other option would not be as close to an ideal gas as the noble gases. And this is because the noble gases have a complete octet. They don't really like attracting with anything else, and they do form van der Waals forces between each other, but that's probably it. Like there are no other forces, and then they're all gases, so they're not very dense, and therefore these are good options for an ideal gas. So ammonia is polar, so obviously cannot be a good choice. Nitrogen, probably there'll be stronger attractions, and the molecule is relatively heavy as well. So again, cross this out. So we have helium and krypton left. Now, krypton is quite low compared to helium in the noble gas series, in the group of noble gases. And as we go down the group, the number of electrons increases, so the van der Waals forces of attractions become stronger, and therefore krypton is also not the best choice, and therefore helium will be the answer here. Then question 9, when hydrogen iodide is reacted with concentrated sulfuric acid, several reactions occur, including this equation. Which row gives the change in oxidation number of iodine and of sulfur in this reaction? So change in oxidation number of iodine. Now, only looking at iodine, we know the H will be in the +1 state, obviously, and iodide will be in the -1. So on the left hand side, and on the right hand side, we have molecular iodine, I2, which is obviously in the oxidation state of 0. So the change in oxidation state is -1 to 0, which is +1, and therefore we narrow down the answers to C and D. And then the change in oxidation number of sulfur. So again, in H2SO4, forget the hydrogen, we know that the SO4 2 negative ion, the 4 oxygens will give total 8 negative, because each oxygen 2 negative, and because the SO4 has an overall charge of 2 negative, the sulfur has to be 6 plus, because 6 minus 8 is -2. So 6 plus in H2SO4, and in H2S, 2 plus from the hydrogens, +1 from each, and then -2 for the sulfur. So it goes from +6 to -2, which is a change of -8, and therefore the answer is D. Now, question 10. The diagram represents the Haber process for the manufacture of ammonia from nitrogen and hydrogen. They've given this diagram. What is the purpose of the heat exchanger? So, to cool the incoming gas to avoid overheating the catalyst. I wouldn't think that's the role of the heat exchanger. I think the gas will be cooled in the catalytic converter itself. And the other thing is, if you cool it too much, then the reaction will be slowed down to quite an extent, and therefore I would cross this option out. To cool the reaction products and separate the NH3 from unused N2 and H2. This is the wrong answer because that's what the condenser is for, this thing right here. That's not what the heat exchanger is for. And you can easily see that the NH3 is coming out from there, and therefore the condenser is doing the separating job. To warm the incoming gas mixture and shift the equilibrium to give more NH3. This is wrong because you know that the combination of N2 plus H2 to give NH3 bonds are forming. It's an exothermic process, and according to Le Chatelier's principle, as the temperature increases, the equilibrium shifts towards the endothermic side, which is the reverse reaction, so you would not get more NH3. So this is also wrong, which leaves us with D. To warm the incoming gas mixture and speed up the reaction. Now, obviously, the most plausible solution, because obviously warming the gas will increase the rate of reaction. Question 11. Which statement about catalysts is correct? They change the reaction pathway by increasing the activation energy. They do change the reaction pathway, but they decrease the activation energy. That's how they speed up the reaction. So this is wrong. They increase the rate of reaction by lowering the enthalpy change of reaction. Completely wrong. Catalysts do not change the enthalpy change. They only change the activation energy. And then they increase the number of particles that have sufficient energy to react. Yes, this is a plausible solution because as the activation energy decreases, there are more particles with energy greater than the activation energy, and therefore more particles with sufficient energy. And then the last one is heterogeneous catalysts are in the same state as the reactant. Completely wrong. This is the definition of homogeneous catalysts. Heterogeneous catalysts are in different states. So the correct answer is C. Question 12. Element X is in period 3. Element X forms a solid oxide Y. Y reacts with hot concentrated hydrochloric acid. So before I go anywhere further, solid oxide, first underline period 3, solid oxide Y, and then Y reacts with hot concentrated hydrochloric acid. Interesting. So that means it can either be a base, probably, so something like sodium oxide, or something like magnesium oxide or aluminium oxide, because aluminium oxide is amphoteric. But anything beyond that, not possible, because the non-metallic oxides are acidic, and therefore they will not react with an acid. They would rather react with a base. And Y reacts with hot aqueous sodium hydroxide to form a compound in which X is a part of an anion. Oh, so interesting. It reacts with hydrochloric acid and it reacts with sodium hydroxide. I am looking towards aluminium because it's an amphoteric oxide. So how many p electrons does one atom of X have in its outer shell? So aluminium has 1 p electron in its outer shell, and therefore I think B would be the correct answer. But let's see the others as well. 0, that's sodium or magnesium. These won't. These have no p electrons, and so these have no p electrons, and they won't be anionic because they like to be in cations, sodium and magnesium. So 0 is not the answer. 2, that's silicon, and the silicon oxide will not react with HCl because silicon oxide itself would be acidic. And then 3 is sulfur. Sorry, it's not sulfur. P will be phosphorus. So P will be phosphorus, and therefore it will, and again P4O10, it's acidic, and it won't react with HCl. So that only leaves us with B. Then the gaseous products of heating a mixture of calcium hydroxide and NH4Cl. Stop right there. Calcium hydroxide with NH4Cl, it's a base with an ammonium salt. It gives NH3, CaCl2, and H2O. So we know this information. Now let's proceed. They are passed through solid calcium oxide. A single gaseous product, W, is collected. Now the only gas I can see here is NH3. So W is NH3. The identity of W is NH3. A sample of W reacts with Cl2 to produce two gases, X and Y. So NH3 reacts with Cl2 to produce X and Y. So this is probably N2 and HCl, because it says that X is an element and Y is acidic. X, N2 element, Y, HCl acidic. So I think we are in the right direction. Let's balance this equation, 2 and 3, and this should be 6. Yeah. So just balanced it because just for clarity. And Y reacts with W to produce Z. So Y is HCl. It reacts with NH3 which is a base, HCl which is an acid, neutralization reaction, NH4Cl. We end up back with one of the reactants of the original reaction. So what are X and Z? So we know that X is N2 and we know that Z is NH4Cl, and therefore the only option that we have for this is B. So B is the correct answer. 14. Q is a mixture of a group 2 oxide and a group 2 sulfate. Q contains equal amounts of the two compounds. Q is shaken with water and the resulting mixture filtered. A solid residue is obtained. There is no reaction when the solid residue is shaken with HCl. Shaking the filtrate with H2SO4 produces a white precipitate. So there is a lot of information in this question. So let's go through it slowly through each option. Barium oxide plus barium sulfate. Now barium oxide and barium, when the mixture is dissolved is shaken in water, barium oxide will dissolve, but barium sulfate will not really dissolve because as you know, the solubility of the hydroxides increases down the group, whereas the solubility of the sulfates decreases down the group, and barium is quite down the group. So this is leading us somewhere because it says that a solid residue is obtained, and in that case this would be BaSO4 right here. There is no reaction when the solid residue is shaken with HCl. Yes, BaSO4 will not react with HCl because it's not a base. And shaking the filtrate with H2SO4 produces a white precipitate. So filtrate, which is BaOH whole twice, because BaO dissolves in H2O. Barium hydroxide, when shaken with H2SO4, produces a white precipitate. If you look at your qualitative analysis sheets, which you need to learn for this paper, you will see that this is the correct because answer, because Ba2 plus gives this reaction with H2SO4. Ba2 plus ions gives this reaction. It forms a white precipitate with BaSO4, and unsurprisingly the white precipitate is BaSO4. So A looks like a correct option. Let's look at B. Now BaO, as we saw in A, will dissolve in water, but MgSO4 will also dissolve in water because MgSO4 is an earlier sulfate in group 2. It will be soluble in water, and therefore we will probably not get any solid residue. So B is not the correct answer. Then let's look at option C. MgO will dissolve in water, barium sulfate will not. So we will get a solid residue and which will not react with HCl because this is BaSO4. However, when we shake the filtrate MgOH whole twice with H2SO4, we will not get a white precipitate because we only get that with barium, not Ba2 plus ions, not Mg2 plus ions. Again, cross this out. MgO, MgSO4, again, both will probably dissolve. So yeah, this cannot be the correct answer, and therefore the correct answer is A. Which substance will not be a product of the thermal decomposition of hydrated magnesium nitrate? Hydrated magnesium nitrate is not the same as anhydrous magnesium nitrate. If you remember, with anhydrous magnesium nitrate, we get MgO plus NO2 plus O2, the decomposition. And if it's hydrated, we will get an additional product, which is H2O in the form of steam. So the question asks for something that will not be formed, and we know that dinitrogen monoxide, probably this is the answer because we do not see this anywhere here. Magnesium oxide, it does form. Oxygen gas, it does form. Steam, it does form. Dinitrogen monoxide, which is N2O, different from NO2, will not form, and therefore the correct answer is A. Question 16. A 5 centimeter cube sample of 0.05 mole per dm cube of sodium chloride is mixed with a 5 centimeter cube sample of 0.05 mole per dm cube potassium iodide. So we have the same amount of chloride and iodide ions in this mixture. 10 centimeter cube of acidified 0.05 mole per dm cube silver nitrate is then added, followed by concentrated ammonia solution. Let's first see what is happening here. 10 centimeter cube of this silver nitrate. So the total total number of moles of chloride plus iodide ions is the same as is equal to the total number of moles of Ag plus ions, because if you do the math, you will get that. So we will get equal amounts of AgCl plus AgI. AgCl is a white precipitate, AgI is a yellow precipitate. And then we add concentrated ammonia solution, which will dissolve the AgCl, but it will not dissolve the AgI. So what is seen after the addition of an excess of concentrated ammonia solution? We'll only see the AgI, which is a yellow precipitate. So the answer is a yellow precipitate, and that happens to be option C. Question 17, the volatility of the group 17 elements, chlorine, bromine and iodine, decreases down the group. First, let's get our definitions correct. What is volatility? It is the ease with which a substance vaporizes. So higher the volatility, higher the ease with which a substance vaporizes. Now let's look at the options. What is responsible for this trend? So bond length in the halogen molecule? No, bond length will not, because volatility is something to do with the intermolecular forces, not the intramolecular forces. So the forces between the molecules, not within the molecules. So bond length, bond strength and electronegativity are all intramolecular. And then the last option is number of electrons in the halogen molecule. Yes, this does affect the intermolecular forces, because remember, the higher the number of electrons, the stronger the van der Waals forces between the molecules. And the stronger the van der Waals forces, the lower the ease with which the substance vaporizes, because more energy is needed, and therefore the volatility will decrease. And this does indeed explain the trend. Acid rain is a dilute solution of sulfuric acid. Which pollutant also contributes to the formation of acid rain? Carbon monoxide? No. It contributes to the formation of probably CO2, but not acid rain as such. Carbon dioxide? No. This is a greenhouse gas. It does something completely different in the atmosphere than acid rain. Nitrogen dioxide? Yes, because we know it is involved in the catalysis in the formation of acid rain, and it probably forms HNO3 as well. So yep, it can be a plausible answer. So I'll cross out A and B, sorry, and C is a probable answer. Hydrocarbons, no, they really burn to form CO2 and H2O. So again, not anything to do with acid rain, and therefore the correct answer has to be C. R is an oxide of a period 3 element, T, and 5 grams of R contains 2.5 grams of T. So what we'll do is that we'll make a table here, and we have 4 options: magnesium, aluminium, silicon, sulfur. So we'll make 4 columns for each option, one for each option: MgO, Al2O3, SiO2, SO2 or SO3, because sulfur can form 2 different oxides, and we'll see which one, if sulfur is if that's the answer, if sulfur is the answer, we'll see which one is correct. So the rationale that we have to follow is that, for example, if we look at MgO, 1 mole of magnesium will form 1 mole of MgO, if it makes sense, because we have 1 Mg in MgO, and therefore 1 mole of magnesium will form 1 mole of MgO. So using this rationale, we can see that the N of Mg, sorry, the N of the number of moles of Mg, which is equal to 2.5 over 24.3, because mass of the element T is 2.5, and the molecular mass of magnesium is 24.3, and this is 0.103. N of MgO is equal to 5, which is the mass of the oxide, over 24.3 plus 16. The molecular mass of the oxide is 0.124. As you can see, number of moles of magnesium not equal to number of moles of magnesium oxide, so this cannot be the answer. Let's move on to option B. The number of moles of aluminium. Now, again, the rationale that we'll be using, that 2 moles of aluminium are needed to form 1 mole of this, because we have 2 units of aluminium in this oxide. So 2 moles of aluminium metal will form 1 mole of the oxide. So using this rationale, The number of moles of aluminium is 2.50 over 27.0, which is 0.0926. We'll multiply this by 2 because we need 2 of this to form 1 of the oxide, and multiplied by 2 gives us 0.185. Then N of Al2O3, the number of moles of the oxide, is equal to 5 over 27.3 into 27.0 into 2 plus 16 into 3, which is equal to 0.0490. Now again, 0.185 not equal to 0.0490, so this cannot be the correct answer as well. Silicon dioxide, we know 1 mole of silicon will form 1 mole of the oxide because there is 1 unit of silicon in the oxide. So N of Si is equal to 2.50 over 28.1, which is 0.0890. And then N of SiO2 is equal to 5 over 28.1 plus 16 into 2, which is equal to 0.0832. Looks similar, but I won't say it's equal. So I'll cross out silicon for now. Let's see what happens with the sulfur. So first we'll take the case of sulfur dioxide. Actually, if you think about it, 1 mole of sulfur will be in both, both 1 mole of sulfur dioxide and 1 mole of sulfur trioxide. So it doesn't really matter which one we use. So I'll start with sulfur dioxide. N of S, which is the number of moles of sulfur, is equal to 2.50 over 32.1, which is 0.0779. N of SO2 is equal to 5 over 32.1 plus 16 into 2, which is equal to 0.0780. Now this is very similar. Like the difference is 0.0001, I think, and that's probably due to experimental error, I guess. So we don't even have to go to SO3. We've already crossed out the first 3 options. D has to be the answer. Then we move on to question 20. Bromoethane reacts with cyanide ions producing propane nitrile. Which statement about the SN2 mechanism of this reaction is correct? SN2, keyword here. Bromoethane, cyanide ions, nucleophilic substitution, propane nitrile. Yep. So what are the options? The lone pair of electrons on carbon of cyanide ions attacks the carbon atom of the CBr bond. This looks like a plausible explanation because we know that propane nitrile, which is a product, looks like CH3, CH2, CN, and and we can see that what is bound to this carbon is not the nitrogen of the nitrile group, but the carbon of the nitrile group. So this clearly means that the lone pair of electrons on the carbon is what attacks the CBr bond, and therefore we will stick with this for now, but let's see what the other options say. The lone pair of electrons on C of Cn negative attacks the carbocation formed when the CBr bond breaks. Now this option is wrong because remember, it's an SN2 mechanism, not an SN1 mechanism. So there will be no carbocation formation. B is wrong. Then option C and D say the lone pair of electrons on N attack the carbon, and they have to be wrong because as we discussed right now, it has to be the lone pair on C, not the lone pair on N. So the answer is A. Which compound would produce 2 different carboxylic acids when treated with hot concentrated acidified manganate ions? So remember, when we oxidize alkenes with hot concentrated acidified manganate ions, a single substituted alkene gives a carboxylic acid, a double substituted alkene gives a ketone, and an unsubstituted alkene, which means a CH2 group, will give carbon dioxide. So which compound would produce 2 different carboxylic acids is the question. So let's look at option A. This carbon will produce a carboxylic acid, but this carbon will produce a ketone because it's double substituted. So this cannot be the correct answer because we only get 1 carboxylic acid. If we look at option B, this carbon will produce a carboxylic acid. Even this will form a carboxylic acid. And because the molecule is not symmetrical about the carbon-carbon double bond, the 2 carboxylic acids will be different. So let's stick with B for now, but we will see what the other options are. Option C. So we have a ring here. This carbon will produce a carboxylic acid group. This carbon will produce a carboxylic acid group, but we are not getting two different carboxylic acids. We only get one molecule with two carboxylic acid groups, because remember, this is a ring to start with. So we will only get a single carboxylic acid, which will be HO2C, CH2, 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 CO2H. That's a single carboxylic acid, because the ring will just form a linear chain, and therefore C is also not the correct answer. Then if we look at D, we have this carbon which will give a carboxylic acid. We also have this carbon which will give a carboxylic acid. But you will realize that the molecule is symmetrical about the carbon-carbon double bond. So we'll essentially get the same carboxylic acid, not two different carboxylic acids. And therefore we can cross this out. So the correct option is B. So which compound could show both cis-trans isomerism and optical isomerism is the next question. So for cis-trans, you know that it has to be a double bond, and no carbon in the double bond should have identical groups attached. And then for optical, there has to be a chiral center, which is a carbon atom attached to 4 different groups. Let's look at option A. Straight away, you see this carbon has 2 identical groups attached, no cis-trans, whereas it has a chiral center. So there will be optical, but not both cis-trans and optical. So A is not the correct answer. B, this is a chiral center. Each carbon is attached to is not attached to any identical groups in the double bond. So B is a plausible answer. Let's look at C. There is no chiral center in this molecule, because as you can see, there is no carbon atom attached to 4 different groups, and therefore C cannot be the answer. And the last option D, this is a chiral center, but again we have one carbon which is attached to 2 identical groups, and therefore and this cannot be the correct answer, and hence because no cis-trans, and hence D cannot be the answer. So we will go with B. Limonene is a hydrocarbon found in the ring of citrus fruits, and limonene, they've given us the molecule. What is the molecular formula of limonene? This is probably the simplest question they could have asked you. So you count the number of carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 carbon atoms, C10. Well, I shouldn't have done that because all options have 10 carbon atoms, but always just to be safe. Then we'll count the number of hydrogen atoms. So there's 3 from this CH3 group. There is 2 more from this one, 2 more from this one, 1 from here, 0 from there, 3 from here, 2 from there, 2 from there, 1 from here. So 3 plus 2, 5, 5 plus 2, 7, 7 plus 1, 8, 8 plus 3, 11, 11 plus 2, 13, 13 plus 2, 15, 15 plus 1, 16, and therefore it has to be C10H16, and the correct answer is C, because that's C10H16. Question 24, the compound cetyl palmitate C15H31 CO2 C16H33 is a waxy solid. And you can first, before we read anything else in the question, you can see this is an ester. This will be the carboxylic acid part. This will be the alcohol part. Cetyl palmitate is heated under reflux with an excess of aqueous sodium hydroxide. And which products will be formed? Before we read any options, let's make the products. Then we will see which one corresponds to our products. So C15H31 CO2Na will be one product. Sodium palmitate, because it's an alkaline hydrolysis, you will not get the carboxylic acid, you will get the salt of the carboxylic acid, and you will get the alcohol, which is C16H33OH. And the only option that corresponds to this is option D. So that's the correct answer. When an organic compound is oxidized, any oxygen atom gained by the organic molecule is considered to be from a water molecule, also producing 2H plus 2 electrons. Any hydrogen atom lost may be considered to be lost as H plus E negative. These changes can be represented by the following 2 equations. So they've given us the 2 half equations. Compound X is oxidized by heating under reflux with hot acidified potassium dichromate for 1 hour. The half equation for the reduction reaction is shown. They've given you the half equation. Under these conditions, 1 mole of potassium dichromate oxidizes 3 moles of X. And they ask what could X be. So for 1 mole of potassium dichromate to oxidize 3 moles of X, we have 6 electrons on the left hand side total, and we need 6 electrons from a combination of these electrons on the right hand side from 3 moles of X to balance the equation. So we'll start with propanol. Now, propanol is CH3, CH2, CHO, and when it oxidizes, when 3 moles of X oxidize, they will give us 3 moles of the carboxylic acid CH3, CH2, CO2H. So if you compare these two, it has for 3 moles we have gained 3 oxygens, and that's it. We have only gained 3 oxygens. So we'll look at this half equation, which I've starred over here, and 3 times this equation is 3H2O plus 3O, 6 plus 6H plus, because 2 into 3 is 6, plus 6 electrons, and 0 from here because we are not losing any hydrogen. So 6 electrons total on the right, 6 electrons total on the left. Balances very well. So I think propanol will be the correct answer. But if you look at the other options and if you carry out the same method, for example, we'll do propanol, CH3, CH2, OH, oxidizes to, it's under reflux, remember, it's written under reflux over here, so it will form the acid, not the aldehyde. 3 moles of this will form 3 moles of CH3, CH2, CO2H, and what we have gained is 1 oxygen, and that's it as well. So but yeah, so we have gained 1 oxygen here, and I forgot, there has to be another CH2 here. So this group has gained 1 oxygen, so for 3 moles gained 3 oxygens, but the CH2OH becomes CO2H, which means it has lost 6 moles of hydrogen, because 2 from each mole, so 2 into 3, 6. So we have gained 3 oxygens, but we have lost 6 hydrogens. So we'll multiply this equation by 3 again, so 6 electrons on the right, but we'll have to multiply the lower equation, this one, by 6. And if we multiply this by 6, we'll get another 6 electrons on the right, which is total 12 electrons. So we won't be able to balance these 12 electrons with 1 mole of this equation, which is just 6 electrons, and therefore B cannot be the answer. And if you repeat this for option C and D, you'll probably see the same, because when we did it for propanol, we got the correct answer. But always check each option, because it's you may have made a silly mistake somewhere. 26. Compound X has the empirical formula C2H4O. Its infrared spectrum is shown below. So sharp peak at 3000 has to be CH. Then we have a strong and sharp peak at around 1700, has to be CO. And I think that's probably all the information we will get in this one. Maybe CO single bond as well, because we have a strong and sharp peak at about 1300. So let's go with that information into the question. Remember, the formula is C2H4O. So the first option, we have 1, 2, 3, 4 carbons, and the empirical formula was C2H4O. None of them have 2 carbons, so we have to look at the molecular formula, which will be a multiple of the empirical formula. So let's go with C4H8O2, for example. Now, so the first option, it has 4 carbons, satisfied. 3 hydrogens here, 2 here, 3 here, 8 hydrogens, satisfied. 2 oxygens, satisfied, and it also has CH bonds, CO double bond, CO single bond. So A is a very good answer for this question. But let's look at the other ones as well. B, it has CO, it has CH, it has CO single bond and double bond, both of them I mean. And but if you look at the molecular formula, we have 1, 2, 3, 4 carbons, satisfied. We have 2, 4, 6 hydrogens, which is not satisfying the formula, because it has to be H8 and not H6. So B cannot be correct. If you look at C, carbon-carbon double bond, alcohol group, raises red flags, cannot be the answer. Because when we look at the IR spectrum, we do not find peaks for these. Then option D is, again, alcohol group, has to be, there's no broad peak at 3000, cancel it out. A is the correct answer, sorry. Then we go to question 27. How many moles of hydrogen are evolved when an excess of sodium metal is added to 1 mole of citric acid? Sodium metal, remember, reacts with both alcohol and carboxylic acid groups. So and it asks for how many moles of hydrogen gas, not hydrogen atoms. So keeping these things in mind, let's look at where the sodium could react. It would react here, releasing one H atom. It would react here, releasing another H atom. It would react here, releasing another H atom. And it would react here, releasing another H atom. So there are 4 H atoms that are released, which is equivalent to 2 H2 molecules which are released. So C is the correct answer because 2 moles of hydrogen gas have been released. Question 28. Which statement is correct for the reaction of carbonyl compounds with HCN? Now, the reaction is catalyzed by concentrated H2SO4. No, the reaction, this is a nucleophilic addition reaction, remember. It is catalyzed by either NaCN or KCN, not by H2SO4. So this is wrong. Option B, pentane 2-one and HCN react to give a chiral product. Let's see that for ourselves. So pentane 2-one is CH3CH2, CH2CO CH3, that is pentane 2-one. This is the second carbon atom. I've numbered them. When it reacts with HCN through nucleophilic addition, we get CH3, CH2, COH, CN, CH3. And if you look at this molecule, there's another CH2 here, sorry. If you look at this molecule, this carbon atom is a chiral carbon atom. And because it's attached to 4 different groups, so B is a good candidate for this question. C, the reaction is a condensation reaction. No, it's not, because no water is released. That's the definition of condensation reactions. And the reaction is a nucleophilic substitution, which is also wrong because it's a nucleophilic addition. And therefore the correct answer is B. Question 29. The table describes 4 reactions of propene and alkene. Which row is correct? Reagent used, aqueous bromine. Remember, aqueous bromine does electrophilic addition onto the alkene. And the product that they suggest is 2-bromopropane. Now this is wrong because there are 2 bromine atoms in the molecule bromine. So, and in the product, they've only given 1 bromine on the product. So for this product to form, we would need HBr and not Br2. And therefore this is wrong. So A cannot be the answer. Cold acidified aqueous potassium manganate. Remember, cold acidified aqueous potassium manganate gives diols when it reacts with alkenes. So the answer should be a diol. Propane 1,3-diol. Now this seems to be correct, but it is wrong because if you look at the structure of propene, CH3, CH, CH2, then you realize that if you number the carbon atoms 1, 2 and 3, the diol will form on 1 and 2, not on 1 and 3. So this answer is also wrong. Option C, hydrogen chloride, 2-chloropropane. Yes, because if you look at option A, 2-bromopropane we said would come only with HBr, not with bromine. So 2-chloropropane will come with HCl. And that's a good candidate for the answer. So let's mark C, but we will look at D first. Steam will give propane 1-ol, they say, but that's wrong because remember the Markovnikov rule. The hydrogen will add on to a carbon that already has more hydrogens, and the other group, which is hydroxide in this case, will add on to the carbon with less hydrogen atoms. So propane 2-ol would form in this reaction, not propane 1-ol, because this is where the hydroxide would add, this is where the hydrogen would add, not the opposite way. So this is wrong. Correct answer, C. Butanoic acid is prepared from 1-bromopropane. The synthesis requires a sequence of 2 reactions. Now, before we delve into the options, let's look at what is happening here. Just draw out the formula always, and you'll get a clear sense of what the question is asking for. So this is 1-bromopropane, and this gives us butanoic acid. There's something odd about this, which is that the reactant has 3 carbon atoms, but the product has 4 carbon atoms. And this starts ringing some bells that somewhere a nitrile, a CN, has been introduced, because remember, the nitrile increases the number of carbons by 1. So if we substitute this with nitrile, for example, by using HCN or NaCN or something, we get CH3, CH2, CH2, CN. Now we have gone from 3 carbons to 4 carbons. And if we hydrolyze the nitrile, remember, we get a carboxylic acid. So the question asks, which compound is prepared in the first stage of the synthesis? It's this one. And that is butane nitrile, and that's option D. So always draw out what is happening in the question so that you can visualize what is happening. And once you're able to visualize what is happening, you'll be able to find the answer faster, and you will be able to find the answer more accurately. So we move on to section B. They have a set of rules here for answering the questions. I don't know if this is still valid, if they still ask questions like this, but anyway, we'll go through them. So question number 31. Ethanol combines with ethanoic acid to form ethyl ethanoate according to the following reaction. So this is an esterification reaction, should straight away come to your mind. What all details are there? It's exothermic, and we have this reaction happening. And what we see is that they've used pure liquids and not aqueous solutions. And I'm just pointing these small details out because we should be prepared for anything that they ask in the question. So 9.2 grams of ethanol, 12 grams of ethanoic acid, and 8.8 grams of ethyl ethanoate are mixed and allowed to stand at 298 Kelvin until equilibrium is reached. And they've given you the molecular masses. That's very nice of them. The resulting equilibrium mixture is found to contain 4.8 grams of ethanoic acid. Now, in these types of questions, I don't know what is being asked later, but I see there is some equilibrium question, there is some numbers that are given. I'll draw up a table to make my life easier. So I draw up a table, C2H5OH, which is one of the reactants, CH3CO2H, another reactant, CH3CO2 C2H5, another reactant, one of the products, and H2O. Now you will say that I taught you that we don't include H2O, but remember, firstly H2O is a product here, and secondly we are not carrying out a reaction in aqueous conditions. So we are using pure liquids, and therefore H2O has to be included. So our first row will be the initial amounts, and our second row will be the final amounts, and by final I mean at equilibrium. So we start calculating the number of moles using the masses they've given us. So 9.2 over 46, which is equal to 0.2. N is equal to 12 over 60, which is also equal to 0.2. N is equal to 8.8 over 88, which is equal to 0.1. Some really nice numbers till now. And we don't have any H2O in the beginning because if you look at the question, they have only given us the first three things, no H2O. So we'll consider it as 0 in the beginning. And at equilibrium, they say that we have 4.8 grams of ethanoic acid. So 4.8 grams of ethanoic acid, which is the second reactant, and we can calculate the number of moles, 4.8 over 60, which is equal to 0.08. So we can see that the number of moles of ethanoic acid has decreased from 0.2 to 0.08. That means 0.12 moles of ethanoic acid have reacted. And if you look at the equation on the top, ethanoic acid and ethanol react in a 1:1 ratio. So that means 0.12 moles of ethanol have also reacted. So 0.2 minus 0.12 gives 0.08 for ethanol as well. And we know that the product is formed in a 1:1 ratio with ethanoic acid. So we'll get 0.12 moles extra of this product, of the ester. So that will be 0.1 plus 0.12, which is 0.22. And we'll get 0.12 moles of H2O. Now we have all these numbers. Now we can read the rest of the question. So they say that the experiment is repeated at 323 Kelvin, which is higher than 298 Kelvin. And which statements are correct? There are 0.22 moles of ethyl ethanoate in the mixture at equilibrium at 298 Kelvin. That is absolutely correct because that's what we've calculated. The equilibrium mixture at 323 Kelvin will contain more than 4.8 grams of ethanoic acid. Now remember, this is an exothermic reaction. We underlined that in the beginning. And an increase in temperature shifts the reaction towards the endothermic direction, which is the reverse reaction. So if the reverse reaction happens, there'll be less ethanoic acid which is reacting or more ethanoic acid that is being produced. So there will definitely be more than 4.8 grams of ethanoic acid. This option is correct. And then if a small amount of water is added to at the start of either experiment, the value of Kc would not be affected. That is correct, because any changes in concentration would perturb the equilibrium in the beginning but would re-establish it, and the equilibrium constant will remain the same. The only thing that affects the equilibrium constant is the temperature. So we have all three options correct, which will give us A. Question 32. The diagram shows an incomplete energy profile diagram for a reaction. So we have reactants and these have lower energy than the products. So immediately it should strike our mind, this is an endothermic reaction. Now, what reactions could this refer to? The first one, calcium carbonate decomposing to calcium oxide and carbon dioxide, of course, because all decomposition reactions are endothermic. Hydrogen gas atomizing to atomic hydrogen. This is also endothermic because atomization is always endothermic. And then chloride ions dissolving, chloride aqueous ions forming gaseous chloride ions and an aqueous solution. Now, remember the reverse of this reaction is hydration, and hydration is always exothermic. So this reaction should then be endothermic because it is the reverse of hydration. So this is also endothermic. Correct answer will be A. Question 33. A gaseous hydrocarbon has a density of 2.42 grams per dm cube under room conditions. What could be the skeletal formula of this hydrocarbon? So remember, so they've given us the density, and remember we treat every gas like an ideal gas unless specified. So room conditions are basically pressure is equal to 101 kPa and temperature is equal to 298 Kelvin, room temperature. And we also know that the ideal gas equation is PV is equal to nRT. N is the number of moles, which can also be written as mRT, which is the mass over the molecular mass, because m over mr is n. They've given us the density. Density is mass over volume. So we can rearrange this equation to give m over v is equal to P into mr over RT. And that's the density. So this expression will give us the density. We know the pressure, we know the temperature, we know R, it's 8.314, it's the universal gas constant. And we know what density we are supposed to get, 2.42. So let's crack on. Formula first, C4H10, this is butane. And the MR will be 12 into 4 plus 10, which is equal to 12 into 4 plus 10, which is 58. And then we calculate the density, which will be pressure times MR. Pressure is 101,123 into 58. Sorry, it's 12 into 4 plus, into 58. And that is, and we divide this by 8.314 into 298. And this gives us 2341 gram per meter cube. So this is grams per meter cube, remember, because per meter cube, because we are using, this equation uses SI units. So we have to convert it to gram per dm cube. It's 2341 gram per meter cube. So this will be equal to 2.34 grams per dm cube. And we want 2.42. We do not want 2.34. So 1 is wrong. Let's do the same for the second option, C4H8, and which is if the molecular formula C4H8, which is the same for both of them. So you can clearly see that if it will be correct for option 2, it will also be correct for option 3, because both have the same molecular formula, and we have to have at least one correct answer. So it has to be both of them, which should give us C, but we'll always confirm because it's always good practice. So we know that the mass mR is equal to 12 into 4 plus 8, which is equal to 56. And the density m over v is equal to 101,123 into 56 over 8.314 into 298, which is equal to 2.26 gram per dm cube. Now, I just realized that I made a calculation mistake. It should be 2.42 in the first one. So I'm sorry about that. It's 2.42 in the first one, and therefore these two will be wrong, because if one is wrong, if two is wrong, three has to be wrong, and one is correct. So that's because of my calculation mistake. I'm sorry about that, and the correct answer will be D. Then which molecules contain at least one bond angle of 120 degrees? C2H4 alkene, sp2 hybridized carbon atom, definitely 120 degrees. PF5, draw it out, always draw it out to avoid confusion. So we have two axial fluorines and we have three equatorial fluorines. And these equatorial fluorines will have a bond angle of 120 degrees because it's a trigonal bipyramidal shape. 120 degrees in the equatorial plane, and this will be correct. And then NCl3 is trigonal pyramidal. The bond angles will be 107 degrees, not 120 degrees. So this is wrong. Correct answer is B. Which statements are correct going across period 3 from sodium to chlorine? The charge on the nucleus increases, pulling the electrons closer to it. That's correct. The radius of the most common ion of each element decreases. This is wrong because it decreases for the metals because they have a positive common ion. The most common ion is a positively charged common ion, and for the non-metals it is a negatively charged common ion, so the radius increases. So it's decreasing first, then it's increasing, so this cannot be true. The shielding caused by inner electrons decreases, so the outer electrons are pulled closer to the nucleus. This is also wrong because the shielding technically increases. The change in shielding across a period is almost negligible, but it certainly increases a little bit because you're adding electrons as you're going across the period. So this is wrong. Correct answer has to be D. Then question number 36. Which statements are correct? Magnesium carbonate decomposes at a lower temperature than calcium carbonate. This is wrong because remember, magnesium ions are smaller than calcium ions. This is right. I didn't read the lower temperature. It says lower temperature. This is right because magnesium ions are smaller than calcium ions. They'll have a higher charge density and therefore more ion polarization, and therefore they will decompose at lower temperatures because less energy is required. Then the second option, calcium hydroxide is more soluble in water than magnesium hydroxide. This is correct because solubility of hydroxides increases down group 2. Calcium is a stronger reducing agent than magnesium. That is correct as well because calcium will want to form calcium will form Ca2 plus ions more readily than magnesium will form Mg2 plus ions because calcium's valence electrons are further from the nucleus than magnesium's valence electrons. So calcium is a stronger reducing agent because it will oxidize more readily itself when it reacts, and therefore all three options correct. Answer is A. And then question 37. 1,1-difluoroethane is less reactive than 1,1-dichloroethane. That is certainly correct because the CF bond is very strong, and therefore this molecule will not 1,1-difluoroethane will not really react because nothing will it will take very vigorous conditions to break the CF bond. It will take a lot of energy to break the CF bond. So this is correct. 1,1-difluoroethane is polar. It certainly is because the molecule is not symmetrical. Both fluorines are on the same carbon. The CF bond is stronger than the CCl bond. That is correct as well because the CF bond is more polar, and therefore the bond is stronger because it has a slight ionic component to it as well. And hence, because fluorine is more electronegative than chlorine, and all these things combined, A will be the correct answer. Which pairs of compounds may be distinguished by testing with alkaline aqueous iodine? Remember, alkaline aqueous iodine only reacts with CH3CHOH or CH3CO. So, butanol and butanone. Butanol is CH3CH2CH2CHO. There is none of these groups here, so it will not react. Whereas butanone is CH3CH2COCH3. And we have a CH3CO group, so both will react. Butanol will not react, butanone will react, and therefore these two can be distinguished. Pentane 2-one and pentane 3-ol. So pentane 2-one is CH3, CH2, CH2, COCH3, and this will react again, CH3CO. Pentane 3-ol is CH3, CH2, CHOH, CH2, CH3. It does not have the CH3, CHOH group It has a CH3, CH2, CHOH group, so it will not react. Again, these two can be distinguished. Propanone and propanol. Propanone will be CH3CO, CH3, has the CH3CO group, will react. Propanol, CH3, CHOH, CH3, also will react. So these two, because it has CH3, CHOH, both will react, and therefore this is also correct. Correct answer A. Sorry, this is wrong because my bad. Both of them will react, so they cannot be distinguished. So the correct answer has to be B, not A. Then question 39, which reactions have a colored organic product? Remember, it's asking for colored organic product, not just colored product. So ethanol plus 2,4-dinitrophenyl hydrazine. Clearly, the orange precipitate that is formed is because it is a colored organic product. Ethanol plus acidified potassium dichromate. The color will change from orange to green, but that's because the oxidation state of chromium changes, not because a colored organic product is formed. So this is wrong because we don't have a colored organic product. And ethene plus cold dilute acidified potassium manganate. Again, this is because the oxidation state of magnesium changes. We'll see a color change from purple to colorless, but not because a colored organic product is formed. So again, this is wrong. Answer is D. Last question. Propanoic acid is reacted with an excess of lithium aluminium hydride. The organic product of this reaction is reacted with ethanoic acid in the presence of concentrated sulfuric acid, forming product X. So decipher the question first, decode the question first, and then we move on to what the options are. So when propanoic acid reacts with LiAlH4, we know that it will be a reduction reaction, and we'll get we'll get propanol, or propanol will be CH3, CH2, CH2OH, or we will get propanol, which is CH3, CH2, CHO, because but the alcohol is because we are using excess of lithium aluminium hydride, it will reduce any aldehyde as well. So I think the major product will be the alcohol, propanol. And then the organic propanol specifically, the organic product of this reaction is reacted with ethanoic acid in the presence of concentrated sulfuric acid. Let's stop right there. This is clearly an esterification reaction, and the product will be CH3, CH2, CH2, O, CO, CH2, sorry, CH3 right away, because ethanoic acid. So this is product X that we are forming. What are major commercial uses of X? Basically, they're asking what are the major commercial uses of esters. Fuel? No, esters are not used as fuels. Solvent? Yes, very widely. Flavoring? Yes, very widely. It's probably present in the shampoo you use every day. So the correct answer is C. And with that, we have finished this paper, the 2021 May-June paper 11. And I hope these things made sense. See you next time.